incredible world of superconductors. Superconductors are materials that, when cooled below a certain critical temperature, can exhibit astonishing properties. Zero electrical resistance. Before that, these superconductors have to be cooled way down. Example is yttrium barium copper oxide, known as YbCO, which can be cooled using liquid nitrogen, or lead, which can be cooled using liquid helium. Zero electrical resistance. In a normal conducting wire, let's say a copper wire, when current is passed through it, the electrons start to flow, but this flow isn't perfect. Occasionally, the electron will bump into one of the atoms, making the atom to vibrate a bit harder. This vibration is the source of heat and is called resistance in conductors. But in the case of a cooled superconductor, it's different. As we cool down below the critical temperature, the atoms hardly vibrate. It's here that something interesting happens. You see, as the electron moves through the atoms, it pulls on them due to their opposite charges. This pull slightly displaces the atoms, pulling a region of them closer together. This makes that region slightly positive. A new electron flowing by will be attracted to this positive charged region, making the electrons form pairs known as Cooper pairs. This way, all the electrons pair up. But won't they scatter later? No, they won't. Why? Electrons are half-spin particles known as fermions, which means no two electrons can occupy the same energy state at the same time. This is why the electrons want to scatter to find available energy states. But when two electrons form Cooper pairs, their combined spin changes from half integer to an integer. This means the pair as a single entity start to behave like bosons. And bosons, unlike fermions, can all occupy the same energy state. Therefore, all the Cooper pairs condense into the lowest energy state. So since there is no lower energy state for a pair to scatter into, they all start to move as a single entity, without any resistance or energy loss. Why should we even care when superconductors are expensive to set up and requires constant cooling to work? That's exactly why scientists are now racing to find